So I'm going to show you a little shortcut here. We've got a situation where we are titrating some sodium hydroxide of a known concentration against a hydrochloric acid of a known volume and concentration. So traditionally what we would do now is we would calculate the number of moles of known, we would look at the stoichiometry of the reaction, we would then determine the number of moles of unknown, and then we would use n is equal to mv over 1000 to then calculate the concentration of the unknown. Now there is a shortcut, and it's m1v1 is equal to m2v2, and where it comes from is using the n is equal to mv over 1000 rule, and we do two calculations at the same time. And the way we do that is, if we were to call this analyte or stuff in the conical number 1, and this stuff here number 2, what we could say is that the number of moles when at the end point, when it's neutral, would be equal to, so n1 would be equal to n2 when you get an equal number of each number of moles, end point or equivalent point. What that means is that it would be m1v1 over 1000 would be equal to m2v2 over 1000. And now, because we've got the thousands on both sides, we can actually get rid of them. So what we end up with is m1 concentration of HCl is equal to the concentration of the HCl multiplied by its volume would be equal to the concentration of sodium hydroxide multiplied by its volume. Now in this case we know the value of m1, 0.1, we know the value of v1, 25, we don't know the concentration, we do know the concentration of the sodium hydroxide, so we're trying to work out the volume needed to get the equivalence point for this reaction. So we just rearrange to make v2 the subject, and we get m1 v1 over m2 will give us our equivalence point. Now if we know the equivalence point, then we can actually then plot what the graph would look like. So this is the volume of NaOH added, and that's in centimeters cubed, and we'll know the pH. We would measure the pH. What we've just calculated there is the volume of NaOH needed, so we would know that the vertical portion would be along that point there. Okay, so the equivalence point there.